In example 3.4.1, we're revisiting the tea and coffee example again. We had the two groups of people. One group drank tea, one group drank coffee, and we were looking at the average interferon gamma levels in the two groups and comparing them. We've already looked at this problem by doing a confidence interval using the standard error method, which will create a 95% confidence interval only by doing the sample value plus or minus 2 standard errors from the bootstrap distribution. What we're looking at now is the percentile method, and in this method we take that bootstrap distribution that we've generated in StatKey and we chop off the outer 5% for a 95% interval to keep 95% in the middle, or we can do other amounts of confidence by chopping off a different amount. So if we go look at the results in StatKey, what you'll do in StatKey to create the confidence interval is we've got the bootstrap distribution already simulated. You'll just click on two-tail in the little box here in the upper corner. You'll see it defaults to 0.95 in the middle, so this is a 95% interval. 95% of the bootstrap samples produced a mean between 1.614 and 32.305 on the bottom. So that is what we would report as our 95% confidence interval. If you want a different amount of confidence, you simply change the value in the middle to the amount you want. So if we wanted a 90% interval instead, we'll put in 0.90, and we'll see that it moved in, and we have more in the outer tails because we only needed 90% in the middle. Now our interval is 3.945 to 29.632. What we're asked to do then in the example is to compare those. So let's jot down the results. We got 1.614 and 32.305 for this one. Then the 90% was 3.945 to 29.632. This interval is narrower. If we go from the lowest to the highest value, the width here is not as much. So we have a narrower interval. So we would think of that as being more desirable, like we've been able to pinpoint a little bit better where exactly our difference in our population means is. But notice also that in doing so, we have only a 90% confidence rate. So we have a lower level of confidence in that this interval is going to actually capture the difference in the population means. So while we prefer this narrower interval, we actually would want the 95%. So there's that trade-off here that will always take place between these intervals. If you're going to be more confident that you capture value, you have to do so in a wider interval. The one fix to this trade-off is always to take a larger sample size. In that sense, we can get a narrower interval without having to budge on the amount of confidence.